Alright, so in this video we go over section 7.5, rationalizing radical expressions. So rationalizing a denominator, it's a process very commonly done in mathematics that consists in writing expressions that have radicals in the denominators in a way that they no longer have radicals in the denominators. So the way we are going to do this is, well, at least this process works really nicely for radicals that have index 2, which in this case is by multiplying numerator and denominator by the same quantity, basically the same quantity as in the denominator. But why this works? Well, let me multiply this across. Well, 1 times 5, 1 times root of 5, that's root of 5. And in the denominator, in this case, it's square root of 5 times itself. That's simply going to be, yes, that is correct. Well, because square root of 5 quantity squared, that's basically what you want to do here. Cancel the index of the radical with the power to give us square root of 5 over 5. And final answer. So really the reason why this works, well, the behind the scenes, if you will, it's because, well, root of 5 times itself, it's the same as saying, okay, 5 to the 1 half, 5 to the 1 half. And in this case, this is going to be 5 to the 1 half plus 1 half, 5 to the first, which is 5. So that's why this works. It's not going to work the same way for other indices. Yeah, I'll show you how those work. Letter B. Well, for letter B, instead of just multiplying by 28x, well, the same way we did it here for letter A. And the reason why we did it like this in letter A, because number 5 cannot be simplified any further. But in this case, the number 28 can be further simplified as 4 times 7. And in this case, well, the perfect square is 4, so take it out of the radical as a 2. Leave a 7x inside of the radical. So now the way we're going to do this is multiply by root of 7x and divide by root of 7x. Alright, so in this case, well, 7 times root of 7x, that's simply 7 root of 7x. And then 2 times root of 7x times itself, well, just like that's the same way we did it. Radical of a quantity times itself, it's the quantity inside of the radical. And then in this case, the quantity inside of the radical is a 7x. And in this case, we can call it a day for these sevens. And that's the final answer, square root of 7x over 2 times x, which is 2x. Don't forget about this x. Final answer for this one. How do we proceed to do in this case, the cube root? Well, would it work to just do the cube root of 3 times itself? Over the cube root of 3? Well, unfortunately, in this case, it's not going to work. And the reason for that, let me show you why. In this case, well, it worked for root of 5 times itself, but a cube root of 3 times itself, it's not going to work because this is 3 to the 1/3 times, use a different color, this one is dying on me, 1/3 times 3 to the 1/3. And in this case, well, this using powers 1/3 plus a third, that's a 2/3. Ultimately, what we want is a 1. So it's not going to work by just multiplying in this way. All right. How are we going to do that? Well, notice in this case, we basically have this invisible 1 that tells us that we have 1 out of the 3. We need 2 more to complete the integer. So 1 times the cube root of 3 squared is simply the cube root, different color, 3 squared over, okay, in this case, what do we have? Well, in this case, what I have is the cube root one single cube root, and then this is 3 to the first times 3 squared. This is 3 cubed. And in this case, just cancel these 3's. And 3 squared is 9, so that's the cube root of 9 over 3. Final answer. Let's do another cube root, and you don't want to multiply by 16 squared times x. Well, in this case, I'm going to simplify the number 16 into a factor in which one of the factors is a perfect cube. And well, how can we factor the number 16 in such a way? Well, the cube root of 16, which is 8 times 2, x squared. Alright, so well, the perfect cube is 8, and the cube root of 8 is 2, and 2x squared. Alright, now it's time to rationalize, but in this case, pay attention to the powers that we have. Well, what do we need? We need a cube root symbol, a cube root symbol. Right, that's good to begin with. What kind of factor do we have? We have factors of 2 and factors of x. Okay, so for the 2's, well, notice I have this invisible 1 over here. That means 1 out of 3. We need 2 more, just the same way we did it with the cube root of 3. I had 1 out of 3. I needed 2 more to complete the integer. Now be careful for the x's, because for the x's I already have 2 out of the 3. That means I only need 1 more. I don't need to write that power 1, but I'm just going to write it just so you can see what we're doing. Alright, so I'm going to multiply across. 5 times the radical is 5 times the radical of index 3 times 2 squared, which is 4x. And then in this case 2 in the denominator, and well, in this case radical times radical with a corresponding power that actually add up to 3. Well, I can simply have it as 2x, and in this case all you want to do is multiply across. 2 times 2, which is 4x. Alright, final answer. Let's do another one that actually involves a big radical of a quotient. So what you want to do first in this case, write it as the quotient of 2 radicals. And then just take it from here. Well, in this case, this is just a square root. 3y and 3y. Alright, so all we do here, well, for the denominator, square root of a quantity times itself, just bring down the quantity that's inside of the radical without radicals. And then for the numerator, notice we're using the product rule, in which 7 times 3, which is 21, and x times y, which is xy. Final answer. Alright, let's increase the power over here. So now we're going to do one with power 4. And then, well, if you observe these numbers, the number 81 is a perfect fourth. But and notice that y to the fifth, this fifth power is larger than that of the index. Well, let's break it down first. And, well, the fourth root of 81. And I'm gonna write this one as y to the fourth times y to the first, if you will. Alright, so in this case 81 is a perfect fourth, and the fourth root of 81 is 3. And then also y to the fourth is a perfect fourth, and in this case its fourth root is simply y. Fourth root of y. Okay, so now we need fourth root x, oh no, not x, actually it's y. Notice the one that we want to rationalize. Now, just the same way we did it with cube root. We had 1 out of the 3, we needed 2 more to complete the integer. In this case we have 1 out of 4, we need 3 more. Alright, so in this case, well, for the root, just multiply the quantities inside, that's xy to the 3rd power, and then divide by 3y times 4 root of y times 4 root of y cubed. That's going to simplify to simply y. And well, all we need to do is multiply those two y's to obtain in the numerator for the 4th root of x to the y cubed over 3y squared. Final answer. Alright, now let's move on to rationalizing denominators that have 2 terms in this case. So, well, when we do that, what we want to do is to multiply by numerator and denominator by the conjugate of the denominator, right? Keep in mind that the conjugate is found by changing a plus sign into a minus sign for the second term, or vice versa, depending on the case. And we will have a few cases in which we're going to do one or the other. All right, so let's see. So also, not exactly like a shortcut, think of the factorization, or of the factorization of a difference of squares, or more properly speaking, the product of 2 conjugate binomials. So because these exercises might be a little bit long, and you don't want to do the foiling, trust me. You might want to just take advantage of this when you multiply a minus b times a plus b, just a squared minus b squared. That's all you want to do. Alright, let's look at one example. Let's see this in action. Well, rationalize the denominator, so I'm going to multiply numerator and denominator by the same denominator. I'm just going to write the numbers first. I have a minus, turn that into a plus. What are we going to have? So multiply across in the numerator. Alright, 5 times square root of 3 plus 2. And then notice in this case what we have is, let me use a different color here. Again, a minus b, a plus b. So you want to have the a squared minus b squared. So all you want to do, again, in what we're applying is this property there. So square root of 3 squared minus 2 squared. So in the numerator, what we're going to do is distribute. That's going to give us 5 root of 3 plus 10. And cancel the radicals. That's a 3 minus 2 squared, which is 4. And that's 5 root of 3 plus 10. And divide that by negative 1. And you might want to divide by negative 1, which is by changing the signs of these two terms. And in this case, negative 5 root of 3 minus 10. Final answer. And as you can see, this final answer no longer has radicals in the denominator. In fact, it doesn't even have a denominator. Let's do another example. So we have 2 divided by 3 root of 2 plus 4. So you want to multiply by 3 root of 2, 4, 3 root of 2, 4. But in this case, the conjugate of a plus would be a minus. So first of all, what you want to do is multiply across the numerator. That's a 2 times 3 root of 2 minus 4. And in the denominator, just take advantage of a minus b, a plus b. A plus b, a minus b. Either way, it's the same. Alright, so quantity squared minus quantity squared. 3 root of 2 in the first case Alright, so what are we going to do next? In the numerator, I'm going to distribute the 2. That's 2 times 3, which is 6 root of 2 minus 8. And then this is 3 squared, which is 9, times the root of 2 squared would cancel each other, leaving us with the 2 only. I'm going to multiply that by 2. Alright, so minus 4 squared, which is 16. So let's just keep simplifying this one, and let's see what are we going to have. So 9 times 2, which is 18, minus 16, and 6 square root of 2 minus 8. 18 minus 16, what is that going to give us? Well, so that's 2 in the denominator, 6 root of 2 minus 8. And then in this case, we can keep simplifying because 6 and 8, both of them are divisible by 2. Alright, so let's see. So what are we going to obtain from there? 6 over 2, that's a 3 root of 2. And 8 over 2, that's negative 8 over 2, that's minus 4, negative 4. And again, this final answer no longer has the radicals in the denominator. In fact, again, this one doesn't even have a denominator. Let's see if it's the same case for letters C and D. We'll see. All right. So we have these are going to start looking a little bit funkier. Okay, a little bit more funkier. So in this case, let's multiply by the conjugate of the. Oh, actually, nope. I made a silly mistake here. Actually, it's only 5, and that's going to be a minus. So minus, that's a plus root of 3. Oh, that was a plus actually. Square root of 5, square root of 3. All right. So notice these two are conjugates. 1 minus, 1 plus. Okay, so let's multiply across. So I'm gonna multiply square root of 6 plus the square root of 2. I mean plus 2. Square root of 5 plus root of 3. And in the denominator, I'm going to take advantage again of the product of two conjugate binomials, quantity squared minus quantity squared, and in this case root of 5, root of 3. What you want to do in this case is simply cancel radical with power, and that's going to give us 2 in the denominator of this fraction. But now, well, in this case, for the numerator, there will be no way around. We would have to otherwise, in this case, FOIL. Multiply these two. And in this case, I'm going to do, okay, the square root. So square root, it's simply the same index. 6 times 5, that's 30. And 6 times 3, that's 18. Okay, 6 times 3, it's 18. And then on the second part of the distribution, 2 root of 5 and 2 times root of 3. So that's simply 2 root of 5 and 2 root of 3. And divided by 5 minus 3, which in the next step, that's going to be a 2. Now, what you want to do for the next step, well, the first, the third, and the fourth term right here, they're going to remain the same. But in this case, I'm going to do something with the second term. Let me first write the other terms. 5 minus 3 equals to 2, and in this case that's 18 reduces to 9 times 2, because that one we can simplify. And again, just like in the previous section, take out the one that has the perfect square, well, the perfect square root, which in this case the square root of 9, which is 3. So square root of 30 plus 3 root of 2 plus 2 root of 5 plus 2 root of 3 divided by 2. And in this case, call it a day for this exercise. We cannot divide all of the terms by 2. So yes, this one has a denominator. I agree. However, that still help us reach our goal, which is get rid of the radicals in the denominator. All right, let's do one more and call it a day for this section. Well, let's see. So multiply by, well, in this case, 3 root of x root of m, 3 root of x root of m. In this case, we have a plus. We need to change this to conjugate, which is negative. All right, so let's multiply across. Well, 2 root of m times 3 root of x minus root of m. And then in this case, quantity squared minus quantity squared. All right, so for the first quantity squared, well, 3 root of x root of m. What's going to be for this? Well, number 1, cancel this radical to give us an m. And in this case, first of all, I'm going to have a 3 squared, which will be 9. And then we're going to cancel the radical with the square to give us simply x. 9x minus m. And in the numerator, what we do is distribute. Alright, so that's going to be 2 times 3, which is 6. Square root of the quantities m and x, which is mx. And then minus 2 square root of m, but in this case, because it's by itself, square this guy. But notice in this case how this radical cancel the second power. So 6 square root of mx and minus 2m, and in this case all divided by 9x minus m. Alright, so let's see, let's call it a day for this video. So I'll see you in the next section.